Hi there. In this video, we're going to find the derivative of a relatively straightforward trigonometric function. And in order to solve this or to do this problem, we're going to have to utilize a whole bunch of different derivative skills, I suppose, in order to get there. So the critical thing to think about is, what pathway can I use in order to work out the derivative? I don't have this derivative form. I don't know what that is. I'm going to have to use some tools to work it out. There are a couple of approaches to it. I'm going to use one approach, and then at the end, I'm going to give you a hint towards a different approach which you could try by yourself. But it's just to point out that there is more than one way to solve a problem. Okay, so we've got f of x equals 1 over cos of 2x, and the fact that it's a fraction makes me think about that quotient rule for derivatives. And in fact, I am going to use the quotient rule for derivatives, which means that I need to match up the top and the bottom to separate functions. So effectively, this becomes my u function, this becomes my v function. And so I'll start off in the usual way with the quotient rule, which is just working out what each of the parts are and their derivatives. So in this case, u is equal to 1. That's a constant value. It's still a function. It's just not a very interesting one. And the derivative of that constant function of 1 is 0. The other function is cos 2x. That's a bit more interesting. The derivative of that function, well, that requires a couple of rules to be used, really, or facts. The first fact is that there is the chain rule. And the chain rule says when I'm working out the derivative of a rather complex kind of thing, I work out the function of the inside bit, sorry, the derivative of the inside bit, and then I work out the derivative of the whole. That's how the chain rule works. So the derivative of 2x is 2. So there's that bit. Multiply the derivative of cosine, which is sine, and then the argument remains the same. It's not positive sine, though. It is negative sine, so the whole thing becomes negative 2 sine 2x. Okay, so that's u dash, v, and v dash. Now, just as a reminder over here, I'll just put it here as a reminder that if you've got the derivative f equaling u over v, these are all functions, not constants, then f dash is equal to, we go inside out. So it's u dash v minus uv dash, and then it's v squared over there. So that's just a reminder. So here we go. We've got, therefore, f dash of x inside out is equal to 0 multiplied by cos 2x, so that's u dash v, minus, and then we've got uv dash. So we've got 1 multiplied by negative 2 sine 2x. So I've got 2 sine 2x. Deliberately left the negative out there because I know a negative makes a plus. So that's a plus in the middle there, all over v squared. So that would be cos 2x squared, but using the conventional language of putting a square for a trig function, we put the square in there. So remember, that does not mean cos squared multiplied by 2x. It means cos of 2x, and then the whole thing is squared. Okay, so where does that get us? On the top, we've got 0 multiplied by cos of 2x is 0, so that's gone. And 1 times 2 sine 2x is just 2 sine 2x. Okay, so that's the top done. On the bottom, we've got cos squared 2x. And we're pretty much done. If you go to your textbook, this was exercise 14a, question 8, and that's what the answer will be. But when I was looking at it before, I noticed that we've got a sine of something on the top and a cosine of the same argument on the bottom. And so my initial thought was to actually take the sine and the cos and go sine over cos equals tan. So we could make that 2 tan 2x over cos 2x. So I've taken the sine from here and one of the cosines from here and turned it into tan, and then I'm still left with a cosine on the bottom. Whether that's simpler than that is arguable, but either form would be reasonably acceptable. That's it for this example.